Chapter 5, Section 5.1 is going to look at the inverse for sine, cosine, and tangent. In Algebra 2, you learn what an inverse function is. It essentially is the function that undoes a given function. And you learn that functions need to be one-to-one in order to have an inverse. When we are talking about the function y is equal to sine of x, we know from our graph that the function is not one-to-one. A function is said to be one-to-one if both the function and its inverse are also a function. So with the case of y is equal to sine of x, this is definitely a function, and the reason it is a function is because for every input, there is exactly one output. If we draw a vertical line anywhere in our graph of y is equal to sine of x, then we have the line touching only in one place. So that tells us there is only one output. However, if we graph the inverse function, if we went and we reflected our graph across this line y is equal to x, we learned in Algebra 2 that that's how you get the inverse graph. You could also switch your x and y values. And when we do that, we get this red graph. This red graph is not a function. If we draw a vertical line, this graph will touch that vertical line in more than one place. And therefore, that's the reason why when we're dealing with the inverse, we're going to have to restrict our domain. So if we look back at our sine function, we want to just take a chunk of this. And we're going to take the chunk that goes from negative pi over 2 to positive pi over 2. And the reason that we do that is because when we reflect across that line, y is equal to x, we end up with this little piece here. And notice that this little piece is now a function. Now that we have made the inverse a function by restricting the domain, we can find inverse function values. And so we're going to focus on just this little portion of our entire sine function, which when we reflect across that line, gives us our inverse graph. So our inverse sine, we focus on the portion from negative pi over 2 to positive pi over 2. In Algebra 2, you learn how to graph inverses by either reflecting across the line y is equal to x or by switching the x and y values. So we're going to define our inverse function here. So inverse sine, or y is equal to the sine or inverse sine of x, you put a power of -1. And essentially what that means is that x is equal to the sine of y, where -1 is less than or equal to x, which is less than or equal to +1, and negative pi over 2 is less than or equal to y, which is less than or equal to positive pi over 2. We have to restrict our domain and our range because we cannot have more than one y value for every x value. And since our sine function repeats over and over, we have to always think about restricting the domain. We're going to be solving things that look similar to this. And so when you're thinking about this or when you're solving it, you want to think about y is equal to the inverse sine of x. as y is the angle or real number, since when we're in radians, radians is just a real number, whose sine value equals 2x. So let's look at an example to help us kind of understand this a little better. We want to find the exact value of the inverse sine of 1. So notice here it says exact value. So what do we want when we think about this? We want the angle theta, or the real number, on the interval from negative pi over 2 to positive pi over 2. Since we have to have that restriction, whose sine equals 1. And we solved some of these. However, everything that we looked at was in the unit circle, and we said sine of some angle is equal to 1. The same process and the same thinking goes into this. However, instead of giving all of the options that are possible, we have a restricted domain. So we only have a finite number of values that are useful in this case. Anything between negative pi over 2 and positive pi over 2. So if we think back to our unit circle, we want to know when is sine going to be 1. And we have angles such as pi over 6 and pi over 4, pi over 3, or pi over 2 in the positive direction. And then in the negative direction, we would have negative pi over 6, negative pi over 4, and negative pi over 3. Remember that sine is the y value. We want our y value to be 1. So the place that it is 1 is at pi over 2. So essentially we could say that we want sine of theta to be equal to 1. And our answer, therefore, theta, is going to be equal to pi over 2. Thinking back to the unit circle, here you have a height of 1/2, a height of the square root of 2 over 2, a height of the square root of 3 over 2, and then when we get to the top, our height happens to be 1. Therefore, the value or the angle that makes this statement true would be pi over 2. Therefore, the inverse sine of 1 is pi over 2. So when you're finding the inverse sine, you're always going to focus only in quadrants numbers 1 and 4. But 4 is in the negative direction. And that is because of the fact that our sine value has to be restricted for outputs from negative pi over 2 to positive pi over 2 to make it the inverse be a function. For number 2 here, we want to find sine of theta, or the inverse sine of theta, of negative 1/2. So essentially, we want to find when is the sine of theta going to be equal to negative 1/2 if theta is between pi over 2, negative pi over 2, and positive pi over 2. So in words, kind of, we want the angle theta on the interval from negative pi over 2 to positive pi over 2, whose sine value equals negative 1/2. We have to remember where our sine value is negative. Everything is positive in quadrant number 1. Therefore, we are going to be in quadrant number 4. And we know it's not 0. We know it's not pi over 2 because the sine value at 0 is 0. The sine value at pi over 2 is negative 1. Well, at pi over 6, we have the ordered pair, the square root of 3 over 2, and negative 1/2. Therefore, our height in here is negative 1/2, and that for the sine value is negative 1/2. So we would say that the inverse sine of negative 1/2 is equal to negative pi over 6. In example number 2, now we are trying to find the approximate value. Therefore, we are going to be using a calculator. Whenever it says find approximate value, you're going to be using a calculator, and we want to have it be in radian mode. So calculator in radian mode. And we know that if we take the inverse sine of 1/3, it will give us an output value. So make sure your calculator's in radians. Mine is in radians. And I want to find the inverse sine of 1/3. So the inverse sine of 1/3 is approximately 0.3398, so approximately 0.34. And we could do the exact same thing with the inverse sine of negative 1/4. Press the inverse sine button, put in negative 1/4, and hit enter. The inverse sine of negative 1/4 is approximately negative 0.25. And that makes sense to have a negative output since our input is negative. And we know that sine values are negative in quadrant number 4. With inverse sine, always check your answer. Does it make sense? So because of the way that an inverse sine function works, you're going to always have an answer that's in either quadrant 1 or quadrant 4. And when we're in quadrant 4, you're going to get negative angle measures. So look at the output that you get and check to make sure that it makes sense in the context of our problem. So all inverse sine answers are in quadrant 1 and quadrant 4 only. And in quadrant 4, we use negative angle measures.